In this lesson, we're going to be looking at surds, and more specifically, how to add and subtract surds. Alright, let's jump straight into it. Basically, the only way we can add and subtract surds is relating it back to algebra and trying to add and subtract like terms. It can only happen when the two surds are the same. So it's trying to compare apples and oranges, really. You're trying to add up the number of apples and oranges you got. You cannot add those numbers together. You can't say you've got 3 apples and 2 apples and 5 oranges, so you've got 10 oranges. It just doesn't work. You need to say you've got 5 apples and 5 oranges. So let's have a look at this in terms of examples with surds. Here we have 4 square roots of 2, and we have another 5 square roots of 2. So if it makes it easier, and I'll do this as a side example, but you don't have to use this when you're doing it, I'm going to say that I've got 4 x's plus another 5 x's. And I'm saying the square root of 2 is x. So I know that if I've got 4 of somethings plus another 5 somethings, I've got 9 of whatever those somethings are. And in our case, that's the square root of 2. If that thought process helps you when you're doing these, by all means go for it. If you know that 4 root 2's and 5 root 2's is 9 root 2's, then go with that method as well. Okay, having a look at the next one. We can see that the surds are still the same, so adding and subtracting is okay. They are like terms. Okay, so to solve this next one, I need to look at it and go, alright, I've got 7 somethings, and I'm going to take away 2 of those somethings. So just thinking about it like that, 7 take 2, quite easy. You've got 5 of whatever you started with left. And in my case, I started with square roots of 3. So 7 root 3, take away 2 root 3, leaves me with 5 of those root 3's left. Alright, last example. By no means any more challenging. We just need to make sure that we take into account like terms. So here we have 5 root 2's, take away 3 root 3's, plus another root 2. So here, I have a root 2, I have another root 2, but in this case, the root 3 is not a like term with the other ones. So I can, and remember when you're adding and subtracting like terms, the symbol before each term sticks with it. So I have 5 root 2 plus another root 2. Now just because there's no number before that square root of 2 doesn't mean that there's nothing there, or that it's 0. It means that there's 1 root 2. Otherwise, if it was 0, there wouldn't have been anything there. So, overall, 5 root 2's and another one is 6 root 2's. The minus sign is before the 3 root 3, so the minus sign sticks around, and 3 root 3 has no other like terms, so it doesn't change. It just simply jumps on the end of our root 2's there. Okay, so that's basic addition and subtraction of surds. Let's get into a couple more challenging questions. Now, I've got 3 here to try, and we're going to go through them rather quickly. So let's have a look. We have the square root of 50. Now what I'm going to do is I'm going to use little side projects and side colours to simplify these surds. We know we can simplify them because they're quite large. Alright, first step for simplifying. We need to write down all those perfect square factors. So 3 squared, 4 squared is 16, 5 squared, 6 squared, 7, 8, 9 squared, and 10 squared. Alright, so they're the numbers that help us do this. Alright, square root of 50 is going to stay in green. Now the biggest factor over the side that goes into 50 is 25. So I'm going to split it up to be 25 times 2. That's the same as square root of 25 times the square root of 2. The square root of 25 is no longer a surd, so I need to change that to a better way of representing it. And the root 2 stays a root 2. Okay, the 32. Now we need to simplify that surd. The square root of 32, we can break it up into being 16 times 2. 16 is the biggest perfect square factor it has. We're going to split those up. 16 times square root of 2. Square root of 16 is no longer a surd. It is now 4 root 2. Alright, the last one. 128. The square root of 128. The biggest factor over here that can go into 128 that I can see is 64. So it's going to be square root of 64 times 2, which gives you square root of 64 times the square root of 2. Now the square root of 64, no longer a surd, it is 8 root 2. Now, starting to recognise the pattern, all our answers have ended up with the square root of 2 in it. We have 5 root 2 plus, because it's a plus sign over here, a 4 root 2, and then the next sign was a minus sign, so it's minus 8 root 2. So 5 and 4 of something give you 9, minus 8 of those somethings leaves you with just one of those somethings left, which in our case is the square root of 2. Lesson learnt from this is just because the surds are not like terms to start with doesn't mean that they necessarily can or cannot be added together. So in our case we could simplify. Alright, this next example, let's have a go. Alright, at the moment there's no like terms, we cannot add or subtract these numbers together. But we might be able to simplify some of these to help us out. The square root of 8. He's going to be our red, and I can see that the square root of 8 is 4 times 2. Splitting that up, I have the square root of 4 times the square root of 2. The square root of 4 is no longer a surd, so I have 2 root 2. Alright, square root of 27 in green. Square root of 27 can be 9 times 3. I'm going to go through the motions, split those up again. Square root of 9 is no longer a surd. It is now 3, and the root 3 gets attached on the end there. Our last one, square root of 18, can be in black. Alright, square root of 18, I'm going to say that it is double 9. Square root of 9 times the square root of 2, I'm splitting those up. Square root of 9 goes to 3 again, and the root 2 is as good as it gets. Alright, let's rewrite this in terms of the simplified form. So that instead of the square root of 8, we have 2 root 2. Then a minus sign. Instead of square root of 27, we have 3 root 3. Then a plus sign. And instead of the square root of 18, we have 3 root 2. Alright, now we have some like terms that we can add together, but not all of them. We've got a couple of square root of 2's and the lone square root of 3 there. So if we have 2 root 2's plus, remember the symbol before goes with it, another 3 root 2's, we have 5 of those root 2's with the need to subtract 3 root 3 from the end. Okay, that is addition and subtraction of surds. I hope you enjoyed the video, and good luck.